most of you would know by now, and Soumya will be talking about lease log support in Gluster and how it can be used for caching in Gluster. So, the agenda for the day, the agenda for the talk would be first looking into what lease logs mean and why it would be needed in Gluster, and the design and what its behavior in network partitions, its challenges and limitations. What's the future enhancements, and how we would be using lease logs for the client-side caching in Gluster. Yeah. So what's a lease log? It's basically used in network file systems. It's advanced sort of logging. It will help in caching. When client cache aggressively. So it's a protocol between the client and server saying. If I have granted you a lease, you can cache that file. I'll intimate you once if some other client is trying to access the same file. It can be granted on a file or a directory, only on a regular file. It is basically used for enhancing the performance and reducing the number of network FOBs to go. So, on a server, let's say a file 1 resides on the server, and you have a client 1 requesting for a lease on file 1. Then, if there are no conflicting access for the same file by different clients, a server can choose to grant the lease for the file 1. Once the lease is granted, client 1 will cache the file 1 on its local storage. Let's say if a client 2 comes in and requests for access to the file 1, same file, then the server would send a lease break to the first client saying flush all its cache data. Then the client 1 will send an acknowledgement and then flush all its contents file 1 to the server and then unlock the lease. Only then client 2 will be granted the access to the file 1. The advantage here is whatever ops client 1 was performing on file 1 can be cached on the client 1 itself until there is a conflicting access. This is best suited for home directory applications or read-only files which are being served. Why do we need the support for it in Gluster? Mainly because NFS and Samba, they have their own manifestations of lease logs, and if we want to support multi-protocol access on Gluster, we need to be able to interpret the leases or op logs. And another thing would be we could use the same lease logs Gluster client being the client which requests for the lease logs, and the Gluster server can maintain a database saying what lease logs are granted. So Gluster client can cache the file data, directory entries including reader plus and metadata. Here, lease logs and its manifestation. So Linux supports lease logs. It supports only 2 types of leases, read lease and write lease. If a file is taken a read lease, that means it can cache the read data, it cannot perform a write. Write lease is an exclusive lease. It's a process based. If one of the FDs sends an unlock, it unlocks for the whole of the process. In case of NFS default, lease logs are the same concept is called by the name delegations. It has a read delegation similar to release, write delegation similar to write lease, and directory delegations. When I mean directory delegations, it means directory's D entry can be cached along with its read plus data. If any file is being modified inside that directory, it will break the directory lease. So, and it's client based per client. So, if once a lease is granted for a file to a given client, any its cache. In case of SMB, the older protocol of SMB had op locks, and from SMB 2.1 they introduced leases. Op lock has three types of op locks. In leases, as you can see, there are a read. So what's different here is the handle-based caching. Handle caching means if a client has asked for a handle-based caching, it can open and close in its local in its local system, and you cannot send the open and close all the way to the server. And the other main change is in case of op locks, if a client had a batch op lock, and if the same client sends another open request, it will conflict its own lock and break the op lock basically. But that was removed in leases. Now it's client based. I hope I'm correct. If not, I think I'm correct.
Yeah, it's correct.
Yeah, it's client based in case of leases. That means a client, once it is granted a lease for that file, any multiple accesses for that file will be served from the same cache. It won't break the lease.
So one addition maybe here, the point of the SMB2 leases is that the client can upgrade the lease. You can start with, let's say, read lease or rehandle, and can upgrade to read-write handle caching. That was not possible with SMB1 oplocks, which is the same thing. You could just, you had to break your own lease, give back the cache, and then require a stronger locking. So this is also why clients usually, they request as much caching as they can.
What do we support in Gluster? How do we converge all these standards and support at least closest to all these standards? On Gluster, currently what we have done would be supports read lease, write lease, and currently is FD based. That means if the same client asks opens two FDs conflicting, we conflict the lease and break if it's from the same client even. But the plan is to move towards client-based caching, not FD-based caching. That way will be more efficient. And we don't currently support handle-based caching, nor directory leases, and we do not currently support upgrade or downgrade. How is it implemented in Gluster currently is a new, it only works with Lease API currently. A new API is introduced, GLFS Advanced Lock, which can be used to request for a lease. Once the request is sent to the server, there is a lease escalator on the server side which has to sit before POSIX locks escalator. The job of the lease escalator is to store the lease info of every file that has a lease granted and check for conflicting access or recall the lease. And it also has timer-based recall. If recall was sent and the client did not respond within given time, it will flush its lease and grant access to the other client. The same thing. What happens in case of network partitions? When the server disconnects and is in irrecoverable state, that means it does not reconnect in a reconnect timer period. A replica will have the lease state. It will serve the lease state. But in case of non-replica, the lease state is lost forever. What happens in case of client disconnects is all the server will flush the logs held by the client. And when a server or a client reconnects within a given reconnect timer, it will replay all the lease logs. The client will replay all the lease logs it has held, and the server will either locks it had held. It can recover the previous locks it had held in case of reconnect. The challenges are in case of rebalance and rebalance, if a file is moved from one brick to another, the lease state is lost as they don't migrate state of the file. Lease locks are not migrated yet. And in case of self-heat, lease locks are not self-heat if is not aware of the lease locks, and it won't be self-heat. Client rock replay, when the server or the client reconnects, the client rock replay currently is not enabled and it has few outstanding issues. When it is used along with the performance accelerators currently laying right behind, we have quite a few known major issues over there. And delegation throttling. Currently, the server can take a maximum of 1,30,000 delegations. That is because that's the inode table size that we support on the server. That inode cannot be removed from the memory if a delegation is taken on that file. And once that limit reaches, it will be a DOS and no new creation. Any new creation of the file will fail. Tracking, so non-FD, when it's a FD based POPs, we can track if for that FD, what client sends, and since we have implemented FD based leases, it's harder to track non-FD based POPs. Harder to find the conflict of a non-FD based POPs. Soumya will continue.
As Poornima has mentioned, we started supporting FD based. Okay. Yeah. Okay, but our plan is to support kind of reachable some rich leases, which can actually kind of provide the semantics for all types of leases present for like NFS protocol or SMB protocol or the accidental leases. Maybe it won't be a superset exactly, but we'll try to follow certain standards which provide more correctness with respect to the leases taken by the applications. So we are still having a discussions regarding that. So we are still into design discussion brainstorming sessions like how to get the correct set of rules, what to support, what not to support. So finally, whatever we support on the cluster, any application, either SMB, NFS or any other Linux application, whoever uses the leases should be able to use this feature, and they shouldn't see any discrepancies while supporting this leases. And then as Michael has mentioned, we have to support upgrade and downgrade of leases. Like if application has taken a read lease and they want to upgrade it to write lease, we should provide that support. And another heuristic based lease grant. Currently, server cannot just grant lease whenever client requests for it. There has to be some set of rules which define when to grant, when not to grant. Some of those are like conflict frequency. Suppose there is a file which is getting frequently accessed by multiple clients, there is no point in granting a lease and again recalling it quite often. So that is one heuristic which server can maintain. And another one is to avoid throttling, which Poornima has mentioned, we can have a limit. Okay, once it reaches the limit, server shouldn't be granting any leases to avoid the DOS attack. And the other one is quota limits. Suppose with quota, like server has granted a write lease, and it's about to reach the file size has about to reach the quota limit, and client, suppose once it grants a write lease, client could be caching huge petabytes of data which may cross the volume quota limit. So server should consider those also before granting the lease. It shouldn't grant the lease in such cases. That's one heuristic which has to be maintained on the server side. And another is we need migration and healing of self-heal of log state. Unlike POSIX logs, here lease logs are not taken by the applications. I mean, as in applications, as in like suppose NFS clients or Samba clients, their applications are not aware of the leases or delegations taken by those clients. So in case if we don't migrate the lease logs during the network disconnects, or we don't self-heal them, the applications wouldn't know about it, and there could be data inconsistencies or corrections. So we really definitely need healing of lease log states to support this feature. And yeah, lock recovery during network disconnects. If when there is the network disconnect between the cluster client and cluster server, cluster client should be able to detect it and replay the loss which it has taken. We need that intelligence on the cluster client. As I'm aware of it, I think the code already exists, but it hasn't been tested properly. We need to enable it and test it and fix the issues. Okay, client-side caching. Yeah, as Poornima has mentioned, one main thing of using these Lease logs is to provide coherent client-side caching. So, what are the challenges of client-side caching currently is it's mostly in memory, so there is not aggressive. But even if they make persistent aggressive caching, they are not coherent across distributed file systems. There are two ways to make it coherent. One is client, like NFS client, they can keep sending the request to the server to check if whatever they have cached is valid or not. Like for example, NFS client, they keep sending a letter to check if file size or something has changed, C time or M time, to invalidate their cache. But that will have performance hit. And or another is, as yesterday we spoke, the server could send file system notifications to the client whenever there is any change in the backend file system. But in case if those notifications haven't reached the client, again it will result in data loss or data inconsistency. So to avoid all those, leases will help that, all those limitations can be resolved using the lease logs. It will provide cache coherency and it will help in aggressive persistent data caching. So we were just talking to Zevi these 2 days, like how we can help the client-side caching. There are certain challenges even with using leases, but we can get over with it. Yeah.
So one of the things that really seems to be a start towards is imagine an enterprise sales staff walk in with a mobile laptop, plug it in, get updates to from their local home directory, sync them across to their laptop. That would be an aggressive, persistent data cache, but they would disconnect it. Therefore, they would no longer be connected. So there needs to be some way for them to get the data across, but also refresh it back. So this seems like it would be the underpin or the foundation for doing that in future, yeah? Because it seems to have the bits in place, but it's not the solution for doing that.
Yes, I mean if there is, the network disconnects, like as you mentioned.
Like, because like a sales staff, they walk into the office, they plug into the network, it mounts the home directory or whatever, or they synchronise their local data that they've updated when they're out on the field talking to clients, and they sync it across to the network, and then they go back out to clients, and that is an aggressive form of data caching.
Or one thing we are just talking to Zevi, like they could take a lease and then they cache it. After a network disconnect or unplug or they replug it, they could validate if that lease still exists. If yes, it guarantees that no other client has.
Yeah, it would need to be as automatic as possible because a salesperson themselves will not know. Okay, so it would need to be something like when it mounts a home directory, like through a Fuse client, would be some option in the Fuse client or something like that. But libgf API at the moment, and I'm just thinking ahead. Sorry, I've interrupted you.
Okay, so it's best suited for the workloads where there's a little write sharing between different clients accessing the same file. And also it's suitable for the distributed systems where there's a larger ratio of local processor speed compared to the network latency. And also once we have direct releases, we could do read plus caching also. So that would help in a lot in lookups, file lookups, creation or deletion. And as Poornima mentioned, it's well suited for home directory, especially because there is very little sharing for the home directories. And it decreases the file creation latency once we have the read plus caching. So roughly it may look like this once we have a client-side caching in our cluster client stack. Whenever any open comes from the application, this client-side caching accelerator could request for both open and take a lease also. And then once the lease is granted, it can cache the file. And whenever there is any conflicting client is trying to access the same file, that would result in lease break. Then this client-side caching accelerator could flush all the data and then unlock the lease. Later, the server would grant the access to the second client. So we are just having sessions with Zavi to how it can be implemented. We see some challenges in having client-side accelerator with the leases, but yeah, we will discuss further challenges in the cluster level mailing list. Yeah, that's it.
Any plans on any plans on having like operational statistics or tools that kind of like a CLI command to like list what leases are outstanding, or even some sort of periodic dumps that can be might need debugging?
Yeah, so state dump, there is a state dump feature in Gluster already which says the statistics we could integrate it in the
State dump.
State dump? Okay.
Yeah, state dump sort of feature which says the current state of that process. For every accelerator, state is dumped. So we could dump in our accelerator how many leases are done and what's the time probably, all those statistics.
Yeah. Another possibility is to actually extend Meta to work on the for the bricks as well. So that could be a way of introspecting each translator in a cluster stack. So you could keep doing CD Meta / Lease.
Yeah, state dumps just tend to be a little heavy.
Yeah, it's heavy.
Like I'm thinking more something along the lines of like every 10 seconds or every minute, you know, it's dumped. Like, because
if you have Meta talking to the bricks and it's keep doing cat on a particular file in a directory, you'll keep getting that.
So if you guys would spit out that patch that adds that statistics type stuff that you were showing us the other day, we could look at maybe doing something with that would be way easy to integrate.
Yeah.
It's way easier when we've got code to see that we can integrate with.
Similar with the current POSIX box actually too, because there's going to be like a POSIX lock reaper and dumper.
Lock Reaper, that sounds interesting,
Well, we're putting a hard stop on like we're putting heuristics around like we don't care if you have the lock or not. We're pulling it because if you're causing a pileup, something's going on.
Right.
Yeah, cool.
Do you have something to say?
So I just wanted to know what you see as heavyweight about the state dumps.
So if we do have a pileup, there could be like 400 men. So to dump that,
It will take a few seconds.
So Meta by itself doesn't yet solve the problem. Meta translator allows you to get a particular translator's state dump. It's not so much as generating, it's just allowing you to serialize a bunch of private to that translator information in a string representation. But that doesn't stop other translators to extend for their particular.
Yeah, and the only other thing would just be like something that's like parsable, like that would be my favorite thing. It's like state dumps also a lot of stuff. It's like with some opting and setting, you can get it into a state that's part of it. It's like consumable, but by themselves it's more tuned to the
There is a portion of meta translate data that meta translate throws out is in JSON. There is a possibility that we can make it all uniformly JSON, unless we have people who say JSON is not the way to do it. Then we can ask them to set a patch to make it.
Yeah, exactly. Like, even if we made it like modular, like we could go write the JSON once and then I'll write XML, like and do it however they want.
Yeah. So it is possible, but only that. But readily you may not get it at low cost, so to speak. Pull the data out and do a little bit more what structure the directory. It's like there are two stats that I want to see more often than the rest.
Yeah. Well, in the access translator, like we've shown, like we dump out like thousands, and like we don't have star performance. Like we can turn it on or off. The graph's not much, so like you can go pretty far probably further than you think before you.
Okay, just maybe comment. I mean, in Samba we have like putting out all the files, logs, and outlogs, and so it's quite a lot. But in that case, it's an expensive operation there. I mean, we maintain, let's say, it's on the file system, it's in databases. Cluster databases, we have to do cluster by traverses to do that, so that's really expensive there. If this metadata is let's say, maintained in a more optimal way here, that would be great. But so generally, traversing and putting out that information may be expensive, may have the performance of the other one.
Yeah, but we just spin a thread and we just have a thread that just dumps it, and we're not even like, you don't even need to like, we don't even care if like, at least you get like, it doesn't have to be like a perfect view. Like, it doesn't have to be like super, you know, locks and like making sure that like at that exact moment, it's completely cohesive. Like we'll trade like a little bit of consistency all the time for like, to make sure we don't have a performance hit. So like, you know, because like what we're looking for is like, is it really ugly right now or is it looking clean? That's
Right,
like,
but if you're doing everything and you're triggering the command on the node of the cluster, this will have to go to other nodes to collect the information. Or you just
so we have them all dump independent of one another.
parallel.
Yeah, in parallel, and then we have systems that'll go soft that for a second. So we leave that problem to like
Something else.
Yeah.
This is actually similar to the discussion that we were having the other day when we were talking about Gluster 4.2, the state translators which we were talking about, which should be responsible to do just this thing. Every translator can send its data in a particular format, and state translator can do what change time recorder currently does. It can send it to a SQLite DB or to any other format which is configurable. And as I said, it need not be perfect. We can convert.
Yeah, like even if there's like a universal, like, you know, maybe built into the X-later structure, like something like, you know, a counter, like something that developers can say, hey, here's this like counter struct that will be handled in a very concise way.
Already have something called dump ops, which data uses. So we could basically figure out ways to say that only this translator needs to dump. I mean, you basically just do a deal open on that.
Yeah, turn it on.
Yeah.
Also, for instance, CTV, I don't know if you've used that. You can do a lot of, can dump out statistics on each node and
Yes, there's like piles of
Congress is much less intrusive and the full information about.
Yeah, really what we're looking for is just like, like counters and you know, in locks we really do need to know like paths really. Because otherwise you can't fix it.
Cool.